if the absolute value of x is less than 2, f prime of x is less than 0. Oh, yeah, this was greater than 0, this is less than 0. If the absolute value of x is greater than 2, f prime of 2 is 0, limit of f of x as x approaches infinity is 1, f of negative x equals negative f of x. The second derivative is less than 0 if, and the second derivative is greater than 0 if this. Okay, this makes no sense. It will, but right now it does not. Perfect. Okay, so this says that the function is odd function. For example, here's an odd function. Whatever we have in the first quadrant is reflected in the third. So x cubed is an odd function. So if you rotate this over the origin, it will overlap. So remember, the function has to be odd. Okay, so this is taken care of. Next, we need to remember what this means. So when the absolute value is less than 2 means this. So between negative 2 and 2, the first derivative is positive. This is exactly what is not here, meaning x greater than 2 or x less than negative 2. And it's negative. So these are taken care of. F prime of 2 is 0. Taken care of. Limit as x approaches infinity is 1. Y equals 1 horizontal asymptote at infinity. Okay, the second derivative between 0 and 3 is negative. And greater than 3 is positive. Okay. And remember what we, and these are already summarized in our table. So remember, whatever we graph in the first quadrant has to have a copy in the third, or what we graph in the second quadrant has to have a copy in the fourth over the origin. That's the definition of an odd function. Okay, then, so what have we learned so far? I've learned that this point could be an inflection point because the sign, look what I did. Look what I did. Sorry, I'm sorry. I put the second derivative sign in the row for the function. Sorry about that. Okay, so then this could be an inflection point. Let's see where this is taking us. Obviously, this is a minimum, local minimum. I don't care what we put in there, we just have to make it work. So this could be an undefined situation or a local max, undefined or 0 for the derivative, or undefined or 0 here, but the local max for the function. The function has to be decreasing and then increasing and then decreasing according to the sign of the derivative. It has to have a local maximum here because the function is opening downward, and it has to have just an inflection point, an increase, opening up, but decreasing. Okay, so let's come up with something that works here. There's more than one correct answer, of course. This is just one example of many. So since the function is odd, I know that it has a horizontal asymptote at 1 towards infinity, but it has to have a horizontal asymptote y equals -1 towards negative infinity, so that whatever I graph here has to be on the other side. Okay, so I have a -2, I have a +2. The function is decreasing to a local minimum here. I don't know where the local minimum is, but it has to have a local maximum exactly opposite symmetric on the other side. So it's coming down, and then what does it do? I have to copy the signs from this side. So between 0 and 3, so this is 1, 2, and 3. So at 3, it should have an inflection point. So it opens down. These have to be symmetric. So between 0 and 2, this could be an option. 0 and 2 has a maximum. Still opening down, but I wanted to have an inflection point at 3. Okay, so then I have to go further down with 3. I have no choice. Okay, so at 0, I can consider it 0 or anything else but symmetric. So if I consider this as being a local max, opening down, increasing to whatever 2 comma whatever, it continues to decrease to this inflection point, opening down, decreasing. It has an inflection point because now it has to open up and approach 1. And that's it. I just have to copy it here. I don't need the table anymore. So whatever I have on this side, I have to have on the other side. Local max, local min. And it's an odd function. Back to the graph. Again, it's increasing to a local max. It's decreasing because between 2 and 3 the function is decreasing, opening down till the inflection point where it has to change concavity, but because now it's opening up, approaching the horizontal asymptote. I didn't copy anything else here because I knew that this part has to be symmetric because of this property. So this is not a pure rational function. A pure rational function will not have 2 asymptotes, horizontal asymptotes, one at 1 and the other one at -1. It must be a